plus 4 cosine 5x. So du, the derivative, the 2 goes away, the 4 would stay. Derivative of cosine is negative sine of 5x, and then you'd also have to multiply by 5, so we get a negative 20 sine of 5x dx for the du. So if I divide that over, I have a negative 1 over 20 du is equal to the sine of 5x dx. So we replace both parts. The sine of 5x dx gets replaced with this. I'm just going to write that negative 1 over 20 out in front of my integral. You can put it wherever. This, the square root of u, since it's on the bottom, can I just write that as u to the negative 1/2? So antiderivative, add 1 to your power, so that would be a positive 1/2. You put a 2 in front. So we get a negative 1 over 10 u to the 1/2. Is that my final answer? No, you have to replace your u, so it's negative 1/10 times 2 plus 4 cosine of 5x to the 1/2. Or you could put it under a square root, either way. Huh? Yes, sorry, I did not have limits on this one, so I should have my plus c on the end. Thank you. All right. Questions on that one? Okay, second one. What'd you pick for your u? The thing in the parentheses, so u would be the 3 plus the square root of x. So du, derivative of 3 is 0. This is an x to the 1/2, so 1/2 comes down, x to the negative 1/2 dx. 1 over the square root of x is that x to the negative 1/2, so I need that. You could just multiply your 2 over, so my 2 du is, if it helps, you could rewrite it as 1 over the square root of x dx, whatever you're comfortable with. So when I replace this, I have a u to the 5th and a 2 du. Remember we talked about changing our limits right now? Because the 0 and 4 are for x. So to figure out what u is, if you plug in a 0 for my x, 3 plus the square root of 0 is 3. If you plug in a 4, 3 plus the square root of 4 would be 5. So we're going to integrate from 3 to 5. So add 1 to your power. It's a 1/6 in front. So we have 1/3 u to the 6th. Since I changed my limits, I don't have to change it back in terms of x. So we just have 1/3 times 5 to the 6th minus 3 to the 6th. And obviously, I made up this problem because it is not very pretty. And we get 14,896 over 3. Probably give you slightly nicer problems on the quiz. But. Is that one okay? All right. I wanted to do a couple more examples, and then I'm just giving you time to work. So if I said the integral of x times 3x minus 1 to the 5th dx. All right. So if I am looking at this, I can't integrate like normal. And unless you want to write 3x minus 1 5 times and multiply it all out, we probably don't want to go that route. We need a substitution. So our u would be the 3x minus 1. Du would be 3 dx. Or if I divide that over for 1/3, du is my dx. So if you look, right now we have a substitution for the 3x minus 1. I have a substitution for my dx, but we have an issue. We still have an x here. When you do substitution, you have to get rid of everything with an x in it. So what am I going to do with just that plain x?
Solve for x.
Okay, you have an equation with the u right here. Could I solve for x right there? So if I did that, I would get u plus 1 equals 3x. So if we divide by 3, that's 1/3 u plus 1/3 equals x. Okay, it's not obvious that this is going to be nicer yet, but it will be. So my x, I'm replacing with the 1/3 u plus 1/3. 3x minus 1 to the 5th is just u to the 5th. And my dx I'm replacing with a 1/3 du. How is this better than what we started with? I still have more than one u. We can distribute now, can't we? So if I did that, I need to distribute the 1/3 and the u to the 5th. So I get 1/9 u to the 6th plus 1/9 u to the 5th. So it was initially uglier, but the benefit is now the thing with the power is just a single u, so we can distribute it through. Then we can integrate. So we have 1/9 u to the 6th would be 1/7 u to the 7th. U to the 5th would be 1/6 u to the 6th. So I get 1/63. U was 3x minus 1. Plus 1/54 times 3x minus 1 to the 6th. Plus c. Okay? Let's try one more along those lines to make sure we're okay with that. So our last example, if I want to integrate from -4 to 4 of x times the square root of x plus 5 dx. Alright, so my u would be x plus 5. So du would just be dx. So I've got this will get replaced with the u. My dx is just getting replaced with a du. We still have this x out in front, so I will solve for x here. So u minus 5 will replace my x. Yeah. Derivative of a constant is 0. Let's go ahead and change our limits. If we plug in a -4, Negative 4 plus 5 is 1. If we plug in a 4, 4 plus 5 is 9. X gets replaced with a u minus 5. Square root of x plus 5 is the square root of u, or u to the 1/2. And my dx this time is just going to get replaced with the d. So this is much better because now the thing with the power is just a single term, so we can distribute. So that's u to the 3/2 minus 5u to the 1/2. So if I add my 1 to the power, put reciprocal in front, we're evaluating from 1 to 9. So 9 to the 5/2 means the square root of 9, so 3 to the 5th, which is 243. Minus 10/3 square root of 9 is 3 cubed is 27. And we get a lovely 29/23 over 30. Okay, so sometimes you may have to do a little extra work if you have more x's that you need to replace. Then your substitution takes care of off the bat. Any questions about that? So we have a quiz tomorrow, and then you'll get your study guides. You have the rest of the hour today to work on this assignment.